or the user stories and get a common understanding. We've all heard a picture is worth 1,000 words. So we can develop those pictures and remove ambiguity of what the ask is, create a solid understanding, and reduce churn. Planning, whether it is actual engineering planning or business planning. And TFS comes with backlog management, the ability to handle sprints or agile cycles, task boards, and to even grow further beyond individual Scrum teams to support scaling agile framework. Tracking and reporting of your projects. Again, with the latest of Update 4 of Team Foundation Server, there's been a tremendous, I'd say, growth and expansion of the charting capability to look at trending right on my team's dashboard. So every day as my team comes together for their daily stand-ups or Scrum meetings, they can see what's happening. We have charts that give us information about where the project is, the build qualities, very robust and visual information. And then it can span on that dashboard across multiple disciplines. So we look at the team itself is ever growing. It's just not a bunch of developers sitting together in a team or QA folks. A team is more of a virtualized entity of all disciplines coming together, including operations, business, developers, and QA. And productivity development, right? Context is everything. It's being able to stay within the tool that you use every day to do your job. Hopefully it's Visual Studio. But being able to debug without having to get up, walk over, try to get into a production environment, or doing memory analysis, or other activities that you normally have to go and step out of your normal zone or productivity environment or tool and use multiple tools. Having it all integrated into one tool set and providing very detailed, rich, robust traceability to other artifacts. Bugs being traced back to business requirements. User stories and tasks, for example. Then we can step into the testing phase. This is where Microsoft Test Manager is integrated back into Team Foundation Server with the defect and test case work items, creating rich test plans, sharing progress of those test plans and status on the core dashboard with charts. And everybody on the team has got visibility. So we're removing obscurity and increasing transparency of overall project status. Getting stakeholder feedback early. This is one of the really awesome features within TFS that I think is not widely used enough. To be able to create feedback requests and have your customers or business partners or key stakeholders get access into, say, a preview environment, test out and kick the tires of new functionality. Are we on track? Are we going to deliver the right value? And being able to collect that information as part of the feedback. Imagine capturing screenshots and annotations and notes from the person or creating that feedback. And that is all captured into the TFS workflow system. So I could have that feedback item linked into a user story. So I'm not switching contexts, trying to chase documents, trying to chase down people, separating it out in emails, etc. It's all incorporated into the one workflow. And then finally acting on that feedback, being able to execute it and incorporate that into my construction process or development process without having to fully release and then start the wheel all over again. Team collaboration, a core component with TFS, incorporating social aspects such as integrating Link or Yammer, and then of course team rooms within Visual Studio Team Foundation Server. Being able to communicate with my team members. This is especially important when we look at distributed teams. Release management, something new and continuing to grow, especially with Update 4 in TFS and what's coming in Visual Studio 2015. Being able to create automated deployment packages, deploying your actual application code, your test code, and configuration, and deploying out to your environments. Being able to track deployments, knowing what is deployed where and when it was deployed, understanding its code quality and deployment quality. Did it pass test? Do we want to promote it into the next environment based on the current quality of tests that were run? And managing that and controlling that. So it's an amount of workflow that you can build into your deployments and have role-based access or approval workflow to promote those environments. Then we get into app monitoring. Being able to automatically and sync monitoring hooks into your application at deployment time, getting feedback about how your application's performing, performance metrics, defects, or application errors, putting that back into Team Foundation Server as either tasks or bugs. So getting information from production in real time and being able to look at it and actually put it under backlog and analyze it. Do we want to fix it now or postpone it? How critical is it? And that leads into a series of actionable diagnostics. And this really, we'll talk about IntelliTrace a little bit later, and this is really what the actionable diagnostics is about. Being able to look at information and pinpoint where in the code an error has occurred. So how do we move beyond? We look at Visual Studio. We want a consistent, singular development platform. And keeping that context, staying within a singular tool to do what I need to do on a daily basis. That's about productivity. Switching context is very difficult, takes time. Getting into the right mindset, finding the right tool. And not only for that, the overhead on IT is significant. So if we're looking at an IT ops perspective, being able to, one, put out all the multiple software, managing software licenses, et cetera, for a multitude of tools. In this example, we can take a look at Visual Studio as a singular platform and development of web applications. So in today's world, we're not just developing applications for a singular browser or a singular device. There's a need to be able to support multiple browsers and multiple devices. But we don't want to create a different code base for every single device or every single browser. Visual Studio has the full capabilities and support of HTML5, enabling you to develop browser agnostic and client OS agnostic web-based applications. You can deploy them to any device and any browser and have them work consistently. The look and feel be exactly the same. Then sitting on top of that is the new one ASP.NET, consolidating all types of web communications and capabilities under the ASP.NET engine. So that enables you to build web applications, Windows or web services, real-time communications, SignalR, for example, all built in on the ASP.NET engine. So now we don't have to worry about, from a development perspective, architectural perspective, trying to figure out how to connect services together with different deployment mechanisms, different configuration mechanisms, and different coding APIs. By unifying it all under one ASP.NET, it simplifies that time and reduces the amount of diversity and code branching you need to do to communicate across your application. And then finally, on the web application front is the server platform. Flexibility to keep on-premise or hybrid or move all the way out into the cloud using Microsoft Azure. Choose your platform what fits best. Windows Server, very complex hosting on internal on-premise if you need it. The ability to switch over to Azure and still what we call lift and shift, move that machine out into Azure as a VM or leverage Azure websites, or even more, leverage Azure Cloud Services. So what about Visual Studio doing development for native clients? So we can't all just build very simple web applications. There are scenarios in which we must build very rich UIs that exceed the capabilities of HTML5. We have to go to the native client, leveraging the native UI. With Visual Studio, this is possible to develop single code or shared code that targets the native UI of iOS, Android, and Windows. This is made possible by using Xamarin. So developing your C# code, all your client logic, moving through Xamarin to your native devices. So Xamarin provides that interface for you, and it's an add-in for Visual Studio. One of the other key aspects here is being able to use portable class libraries, or the ability to write shared code and compile it once and deploy to multiple devices. Again, I can focus on a singular code base, a singular build, and deployment out to any of my devices. Or without portable class libraries, you still can enjoy a singular code base, but build and target multi-platforms. And all within the Visual Studio API. I don't need to switch over to other development platforms or develop 3 individual code bases and manage those. So again, the complexity of fixing a defect across 3 code platforms is now simplified into a singular code base. So what is it that we like about Visual Studio and the new features that have been implemented and their continuous improvement in these capabilities, especially around developer productivity? These are my favorite types of discussions, is how do I get the ooh factor or the awe factor out of my development team? How do I keep them moving and efficient? And realizing in today's world that employee turnover is going to happen. We have large legacy code bases, and we do not, at most of the time anyway, develop and deliver brand new application code. Most of it's about maintenance, either if it's new code or within a year, or legacy code. And it's code that you've never worked on before. So onboarding a new person into a project team is a very time-consuming effort to understand and learning where that code base is, what it looks like. This is where CodeLens can really significantly help in solving that problem or reducing the time to become efficient and effective on a new project. So the first scenario I'd like to cover with CodeLens is, again, it builds metadata on top of each method or class, if you will, and tells you information about the code about it. So in this case, I'm showing a scenario in which CodeLens is telling me that this parse term is referenced in 2 other places. So I can use this information to say I have to make a bug fix, or I want to refactor parse term and change its behavior. What type of impact is it going to have? The old way is to go and make the change, maybe compile it. If it passes compile, run some unit tests if we have unit tests. And hopefully everything works. Now with CodeLens built in, I don't have to go searching for any reference code or finding and searching documents or architecture diagrams. CodeLens tells me there's 2 references. Then I can highlight a reference and actually see the code implementation or how that object is being used. Make a conscious decision on what the change is and look at the impact in real time. And now I don't have to go switch context. I stay in the mindset of what I have to do. I can see the impact or how it's being used or what it does. I don't have to understand the code base. It's all given to me right there within the CodeLens window. Unit tests. I get visibility into the number of unit tests that are impacting or testing a method, and their past failure rate, and how long they take to run. So we can imagine multiple scenarios here. And again, I make a code change. What do I do about the unit tests? I can specifically choose to run and execute a singular unit test or run them all. If my task is to fix these broken unit tests, I can run one, get the diagnostics and information about where it's failing, and then step into that and start debugging it, all from within the context. So let's see, I see a question here. Let's see, and VS10 had the possibility to right-click a method and do a create unit test. This is available, and on the, I believe, the Ultimate and Premium Visual Studio SKUs to create unit tests. And what it does is it creates a shell. It doesn't create the implementation. So a new feature coming in Visual Studio 2015 will even address that further. So code history, being able to see how many changes have been checked into source control. So over time, how has this code base changed? Telling me which version of that code base do I have on my machine locally, and if I'm up to date and who's made the changes. So yeah, you're bringing in social or team information together, so it's easy for me to communicate with my team members when a change happens, and how does this impact me? Then work items. We talked about traceability and Team Foundation Server, and how you have work built in. So again, with CodeLens, I can see the work items that are associated with this piece of code, whether they're tasks or defects, user stories, etc. I can explore those work items and see information about it. So as people make changes to code, I can understand the reasonings why changes were made. I'm not dependent upon inline comments. And if it was inline comments, how many business folks or testers could find it? Now it's all linked, integrated within the Visual Studio IDE. You're not switching tools in context. Again, maintaining that I'm in the zone efficiency. Same for code reviews. So code review is just like any other work item in TFS. So now I can look at how many code review requests, what state, and the information about them are related to this particular method. And then finally on CodeLens, user presence. So we've all had those WTF days when a coworker has made a change, doesn't document it or why it was changed, and there may be a relevant code break and functionality somewhere else. So here I can quickly get the availability of that individual that made the change and many options to be able to communicate with that individual. Whether they're online in contact through IM or even just sending simple email. The next one that is really of importance to me is the suspend and resume capabilities. So how many times have you had a manager or someone else come and give you the tap on the shoulder while you're deep into developing a new feature? The tap comes and you're asked to go look at a production problem. You've got several files checked out. You've got a bunch of tasks that you're working on that are part of that checkout and what you're doing. You're in flight. You have a source control window open in your IDE. You have several files opened. Now you need to close all that down and switch into trying to get into debugging some other issue somewhere else, unrelated to the work you're doing. It could be not even the latest code base. It could be a code base that's 4 years old. So with a suspend and resume feature, I can actually take all that work I'm doing and suspend. And Visual Studio will create a change set and shelf set of all the code that you have checked out. It understands all the work items that you have active or working on. It will capture every state of the windows that you have open and put that in as a work in progress that you can resume at a later point in time. And then you can go focus on that production bug or production issue that you've been asked to go look at. Then when that's solved, I can go back and resume and have my complete IDE restored to where I was. So again, I don't have to do a whole lot of work. It's very easy to get back into the context of where I was. My IDE is restored to where it was. The shelf set that was done is recreated and brought back in. Gives me the code that's checked out again and gives me back the state of the work items that I was working on. So the next part of a developer's task is, again, we're significantly spent in the debugging phase. As I said before, we're mostly working with legacy code in some form. And then this is where code maps come in and really shine. As discussed before, most of the time we're not working on our own code. We're most of the time working on others or legacy code and not familiar with the code base. Or if you are, you don't know every aspect of the code base. Or it's changed over time. So with code maps, gives you a visual way to navigate your source code and look at dependencies. Code maps, in this scenario, in the code map diagram, I have a green arrow and a yellow box around the object that I'm looking at. And then I can navigate through my code and see how that changes. And it brings up the objects and gives you symbols of what type of object that is. Being able to visually see relationships in my code. So not only see references, but how an item's used and its other dependencies. So again, if I have to make changes to a piece of code, what is the impact that I'm going to make? Being able to explore that impact. Are they referenced objects? Are they new objects that are held and created by my current object? Walking the code map, it enables me create inline comments, which are here annotated in yellow. And then I can question and put things in red to highlight what's wrong or an area to fix. And then with that code map diagram, I can share that diagram. So that is code maps. A very interesting and I believe an underused item out of Visual Studio. And this came into and was updated again with Update 4 and increased its capabilities. And with Visual Studio 2015, it continued investments in code maps and CodeLens. So I forgot to mention this in CodeLens. With the latest update, CodeLens is starting to work with Visual Studio Online. So if you use source control there, you're not only stuck with or have the ability to use CodeLens with an on-prem TFS instance, but now with VSO. So this is my favorite of all the debugging capabilities with Visual Studio. And this is IntelliTrace, which has been greatly improved over the year with TFS and its capabilities. And the most important to me when I look at IntelliTrace is to be able to do pinpoint debugging of what is happening on systems that are not my local machine. Yes, before I could do IntelliTrace on my local machine and step through and debug code locally. Very helpful, especially if you don't have or familiarity with a code base. But the key for me is to be able to debug something that happened on a tester's machine or something in production. Being able to pinpoint exactly where in the code a defect arrived or a problem arrived. So being able to take that IntelliTrace and that data, bring it up into my Visual Studio IDE and sync it to the code and see the full call stack of every method that was called into and its process, the variables that were used and set to see what is actually happening in a live system. I don't have to go to my operations person, sit over their shoulder, and try to get them to repro it and to see what happens and then go back to my code and figure out where in the code this is happening with an exception message, for instance. And with this, I could take that exception, drill into that exception, look at the call stack, look at the locals, and then even step through the code before and after and get a good handle on what is actually happening. We have two modes in IntelliTrace and the level of information. First mode is the events mode, which is just capturing basic events that happen. You don't get rich, robust details and variables and values in this mode. And this is a good general performance mode that won't have a negative impact on application performance. Switching into a full calls mode, this is going to collect additional information and metadata about the code running and will give you that full call stack and information about what is actually happening within each method call. So how do I configure this? On your Visual Studio client, it's just a part of the options, and as you can see here, there's quite a few pieces of information that you can configure in the level of collection of data and events for IntelliTrace, for your production servers and test environments. And you can create a configuration file that tells you the detail and level in which you want to collect for IntelliTrace. And the greatest of here is, for me, is, again, where these errors occur on applications that don't belong to me. Having that IntelliTrace file automatically added as a link into a defect. So I don't have to really depend on repro steps or the accuracy of them. I can look at what was done for the repro steps, but then also pair that with an IntelliTrace file and get to the actual line of code that caused the problem. So next is deployment. How do I do deployments? Well, first option now is we can look at Visual Studio Online in Azure as an example, and how easy this has now become within Visual Studio and connecting up to VSO and Azure. So the first thing I'm going to do is create a Visual Studio team project and use that for source control. Then I'm going to switch over to Visual Studio and create a standard ASP.NET website. And again, I could do this for a POC, or I could do it as a small engineering team. And this is the website that I want to work on and produce and deploy. I'm going to put that code, or that ASP.NET website code, into source control in VSO. In VSO, I'm going to create a build for it. So with this, I'm not even having to create the build infrastructure. This is all taken care of for me by Microsoft within the VSO platform. And on that build, I'm going to set it up for a continuous integration or continuous deploy type build. So every time there's a check-in of code, I'm going to deploy that code. So I'm going to use a special template for that available in VSO. So now I've done that and completed that in my process. I'm going to go and connect my VSO project to Azure. Once that connection's made, it's basically connecting your build mechanism to be able to deploy out to an Azure website. And you need your subscription credentials, et cetera, to do that. And that's what mapping the project does. So now anytime I make a code change in Visual Studio and I check in that code, it will auto-trigger a build. That build will auto-deploy out to my Azure website into my staging slot. So then I can go in and validate and run tests against that website of all my new code changes. Next is cloud deployment projects. This is still fairly new and actively being developed and continue to improve. This is looking at infrastructure or configuration as code. So in Visual Studio, I'd create a website project and what we call a deployment project. So there's separate code projects in Visual Studio. The deployment project is pretty much a wizard that will create a JSON Azure release or resource manager template that tells how to deploy your code into Azure. I'm going to take both these projects. I'm going to check them into source control. I'm going to create a build definition that builds these projects that is meant for continuous deploy. Then I'm going to take those and push this through Release Manager. So I want workflow or process. So I want to get real DevOps-like. So in Release Manager, I can create multiple environments and choose and control how things are deployed. And with PowerShell, I can actually execute that deployment project and deploy out to an Azure website. And then also with Release Manager, execute tests against that website. So those are the two common or two great new improvements I see in Visual Studio for continuous deploy support and simplifying this. So what's next? Visual Studio 2015 is right around the corner, and you can experience it now. Minimal risk. You don't need to go and install it on a machine. You don't need to go to IT and say, hey, I need another machine, or your manager. I don't want to clutter up my current machine. So how do I do this? You'll get yourself a free Visual Studio Online account. Then go and get yourself your free Azure trial subscription. Then within that Azure trial subscription, create a brand new Windows Azure VM with Visual Studio on it. It's either CTP, 5, or 6. Take your pick. So now then once that VM is created, you connect to your VM and you can explore all the new features of Visual Studio 2015. So what I think is really interesting with 2015 around productivity within the Visual Studio IDE, they may not be super exciting, but when it comes to productivity and quickly moving me through code bases and making decisions and editing and modifying code, as a developer, that's what I see as super important. So outlining. So currently today, we collapse code and we have an outline represented by this ellipsis. And then you can hover over it and you see very simplistic of what's inside that collapsed outline code. 2015 is now colorizing that so it looks like your regular code base, not the drab gray or black, but now whatever your color scheme is and how you want to highlight objects and items, the same color coding is applied. So you stay in that same mindset, same context, and you get an idea of what is in your code. Looking at symbols or classes. Getting into color coding around the class definition and its parameters. Digging in, now I'm highlighting a method on that, seeing the method signature, and all the details about that color-coded. Before, it was just a drab gray. And here's my favorite. is static code analysis. Before, static code analysis had to be manually run. You had to force people to do it. Now with 2015, this is actually automatically done. To have your static code analysis rules done and executed. What's great here is removing code that's unused. So over time, code changes. You're using statements. You may be prototyping something and you make a change, but you never remove that using statement. So within Visual Studio and the new static code analysis engine and making it real time, it will actually turn the unused directives or your imports into a lighter color, making it obvious that these are not used, thus making it easier to detect and actually remove those using statements. Simplifying your code. Less dependencies, less opportunity for error. The inline error warnings with whether it's a warning or error condition on your code that you're actually developing or have developed or templated. So what does it mean? Before, it was not that easy to understand what that error was referring to. Now I can hover over it, I'll get a light bulb, and it gives me recommendations of what to change and why. I can also show the potential fixes. I'm given all the potential fixes and what it does and the actual violation number. So in this scenario, I can see it's CS0535, and then I have options of way to fix that. And then I can highlight each recommendation, and it shows me what those changes are going to be. I can preview all the changes in the entire solution, project, or the current code file and accept it and automatically implement it. Refactoring support. With this, it's happening is we're making refactoring extensible. So before you had limited menu choices on how you wanted to refactor your code. If you've got a specific way or a pattern that your organization you want to follow, you can implement your own refactoring patterns or extensibility and add that to Visual Studio. So in this scenario, I'm inlining a temporary variable. The other scenario is an inline rename. Before, it used to be a whole new window, separate context. I don't have real visibility into my code. Now with the inline renaming, it's there. I can see where we have conflicts. In this case, args has got two different meanings. It highlights that and gives me visibility to it and how I want to manage those changes. So these are the three things that I've seen so far in Visual Studio around managed code. Of course, there's a whole lot more, especially what's being done with C++ and the .NET runtime. Significant changes are coming. Again, go explore for yourself. Right? Go get your Azure subscription, your VSO account, and create a VM with Visual Studio 2015 on it and start exploring. No risk. And with that, I'd like to conclude and say thank you, and I hope you appreciated the presentation.
Thank you, David. That was very outstanding and insightful. At this time, I'd also like to remind everyone about our contest again. We are giving away an Xbox One, and to be eligible to win, you simply need to retweet or share our webinar announcement on LinkedIn and complete a post-webinar survey with contest details, which can be found in the participant email I sent earlier. If you have not received that, my email is in the on the screen right now, so please send me an email and I will send out the contest email to you. It will be open between now and our next session on March 17th, and the winner will be randomly selected from participants that are kind enough to retweet or share our announcement on LinkedIn. At this time, we have about 5 minutes for questions, so please enter them in the chat box if you have any. To enter I just wanted to answer the question. To enter for the contest or survey, an email has been sent out, and there are links where you can click to share on LinkedIn or tweet on Twitter, and also there's a link for the survey.
So, Vimal, yes, there's plenty of new support for JavaScript and TypeScript. It's pretty much a first-class citizen now within the IDE, so very rich IntelliSense and color coding. And I also believe CodeLens has been added to support JavaScript. I am not sure about profiling for JavaScript within VS 2015. I know they've really improved the overall performance and profiling tool set. I don't know how much they've actually made investments into 2015 around JavaScript.
I see there's another question around grunt automation while configuring continuous deployment.
So I'm not familiar with Grunt. Is that a test framework similar to unit test or NUnit?
Thanks, David. Are there any other questions? It's being asked, is this supported in 2015?
The task runner, I think I want to JS as part of my release process. Yes, this will be something that you'll be able to do in 2015 with Build V Next for sure.
We still have about 3 more minutes. Any more questions? Another question about Grunt. Is this supported in VS 2015? But he wants to know if this is supported in continuous deployments.
How you manage continuous deployments, it depends on how you want to do this. So with Release Manager driving those deployments being completely scriptable, right? So you can create custom modules that are based off of PowerShell or DSC or chef recipes for that matter. So as long as you can invoke and grab that through the deployment process or even in the build process through customized build tasks.
Another message is coming in. Okay. And there's 1 more minute. Any other questions? Okay, if no other questions, you can either email Stephen, as you saw his email in the chat window, or you can email me, and I can forward them on to David to answer. So I just want to let you know about some great programs and offers. Microsoft Build is currently sold out. However, you can watch it streaming live April 29th through May 1st. And Visual Studio Online, did you know that VSO is free for under 5 users? So be sure to get started today if you're not already using this tool. The last program I want to mention is Microsoft's Architectural Design Services, or ADS. Microsoft Azure provides a great opportunity if you or your company are considering Azure. Microsoft is offering up to 5 days professional consulting to help you with your migration to Azure. And then I just want to wrap up. That's all the time we have today. Thank you again, David, and to the great folks at Microsoft for not only supporting this webinar, but also providing today's Xbox One, which is a great giveaway. If you haven't already checked, contest details are in your inbox. And as we conclude, please follow us on Twitter at InCycle Software or on LinkedIn for more upcoming events. Thank you, and we hope to see you again. Thank you, everyone.